Check it out. In exercises 1 through 3, notice the box. The box is covering up 2 and 3. Point Q is the centroid of JKL. Use the given information to find the indicated segment lengths. If AQ is 21, what would QL be?
QL is 42.
Giselle?
42.
42, baby. This one's 21. This one's 42. What's the length of AL?
63.
63. Easy, right?
Yeah.
Okay, just remember, if they give you that tiny little segment, you multiply by 2 to find the larger segment, or you can multiply 21 by 3 to find the length of the whole thing, right? Yes?
Since I did that exactly, can I just copy and paste it to your slide? Because I did that.
That's fine, yep. Just make sure that there is something on both slides, okay? Whether it's the exact same thing or not, that's up to you, okay? But I do need something on both slides. Today, okay, and that segment is called the mid segment, okay? Now, be very careful. I want you to write a little note to yourself. It's super similar to the median, okay? It's super similar to median, but not the same, okay? Now, does anyone remember what is a median? It does involve the midpoint, but it goes from a midpoint of a side to where? To the opposite vertex. A mid-segment, okay, and we'll talk about it in a second, it goes from midpoint to midpoint, okay? So I'll show you in a second. It goes from midpoint to midpoint. Do we all have that copied down? Okay? So, the mid-segment, the definition is it's a segment that connects the midpoints of two sides of the triangle. And every triangle has exactly 3 mid-segments. And those form what we call the mid-segment triangle. Now, this slide needs a lot of writing, okay? So, over on the left, I also need you to write that the red triangle is our mid-segment triangle. Okay? Now, if we were to take the point M, for example, and draw the line to C, what kind of line did I just make? A median. Okay? Do you guys see the difference between that median, the yellow one, and the red ones that they have on the page? Okay? This yellow one is a median. The red ones are your mid-segments, okay? If you don't want to write that in because it gets a little messy, okay, you don't have to, right? But I just want you guys to notice the difference. The yellow one I drew, which was from a midpoint to a vertex, that's a median. Your mid-segments are going from midpoint to midpoint, okay? How do we know that P is the midpoint of BC? How do we know, based on this diagram, that P is the midpoint of BC? Xavier? Very good. It's because of those congruence marks, okay? That tells us that P is the midpoint, okay? It also tells us that N is the midpoint, and it tells us that M is the midpoint. Got it? Okay? So in your problems, right, it'll tell you whether the line is or the segment is a mid-segment, or it'll tell you that the points are midpoints. Got it? Yeah. I don't have any, unfortunately. Okay? All right. I want you to write one little question for yourselves. Where do the mid-segments all meet? So, do you guys remember when we talked about perpendicular bisectors? Those all meet at the circumcenter. Do you remember when we talked about angle bisectors? Those all meet at the incenter. When we talked about altitudes, those all meet at the orthocenter. And when we talked about medians, those all meet at the centroid. Where do all the mid-segments meet? It's a trick question, guys. They do not meet, okay? and write down in all caps, they don't. Okay? So this is the only one, right? The rest of them, the ones that we've covered, they all met at one point, right? Do you see how these don't all meet at one point? They're going to form another triangle, okay? They only touch another line. They don't all intersect at one point. Got it? So there's no point of concurrency, okay? Because concurrency means that 3 lines are intersecting at the same spot. Mid-segment theorem, okay? Now, what the mid-segment theorem says is it says, okay, if you've got a mid-segment in your triangle, okay, that mid-segment is going to be parallel to one of the sides of the triangle, okay? And it's going to be parallel to the third side, the side that it's not a midpoint of, okay? So, do you see how D is the midpoint of AB and E is the midpoint of BC? Then DE is the mid-segment of the triangle, and DE is parallel to the side that it's not a midpoint of, which would be AC, okay? It's pretty obvious once you draw it that it's parallel to only that line, right? Because it can't be parallel to AB and it can't be parallel to BC because it intersects them, right? It passes through its midpoint. Now, not only is it going to be parallel to one of your sides, but it's also exactly half of the length of the side, okay? So DE is exactly half the length of what AC is, okay? So there's 2 parts to this theorem. There's the parallel part, and then there's this formula where whatever side it was parallel to, it's also going to be half the length of that side. All right, any questions so far? All right. Examples. All right, so the triangles are used for strength in a roof truss. I don't know what a truss is, okay, but we're going to use this example. In the diagram, UV and VW are mid-segments of SRT, okay? Before we do anything for finding UV and RS, let's take this sentence and let's apply it to our diagram. So let's start filling in with congruence marks and parallel stuff, so we know exactly what we're talking about. So UV and VW are mid-segments. So if UV, let's highlight it, which is this one. If that's a mid-segment of the whole triangle, what information does that tell us? What can we start to fill in? Emma, go for it.
I know.
Just give me one thing.
That, I don't know. No, I know. Wait, no. I said a second.
Just give me one thing, Talia.
Doesn't RV? Oh no! Isn't that like
Wait.
bisector?
Give me a chance.
Nope. Savannah?
That since like the midpoint to each one, that SU and UR are both congruent.
Excellent. Hold on. Don't give away the second one. So we know that SU and UR are congruent, right? Because it's a mid-segment. So it goes U is a midpoint. V is also a midpoint. So what else do we know? Xavier?
SV and VT.
Excellent. SV and VT are congruent. What else do we know? Emma?
That it's parallel to RT.
Excellent. This mid-segment is parallel to the side, the bottom side of the triangle, and there's one more piece of information. Xavier?
VW is parallel to SR.
No, we're still just involving UV.
Oh.
Still involving just UV. Remember, the mid-segment theorem had 2 parts. We used one of them. We said it's parallel. What else?
Is it something about being a
No.
I think
Christian?
UV is equivalent to WR and WT.
Ah.
Huh?
Yeah, it was gonna
UV is exactly 1/2 of RT. Okay?
So it's congruent.
It's not congruent.
What? It's not congruent. UV is not congruent to RW.
It is congruent to RW, but it's 1/2 of the full length, which is RT.
So we don't need to put any.
Okay, so, well, do we know what RT is?
No.
It's 90. Do you see that?
Yeah.
Okay, so let's use that 90. Let's say UV is equal to 1/2 of 90. So what's UV?
45.
UV is 45.
Wait a minute. So that's what RW is.
Now, RW is going to be 45 as well. Very good, okay? Because W is the midpoint, okay? But you didn't know that, Janalis, unless they said, do you see how it says VW is a midsegment? You would not be able to say that RW and WT are the same unless it told you that VW is the midsegment, okay? Now, let's highlight VW in blue, and let's fill in all the information about VW, okay?
It's side side side.
Okay, so let's fill in all the information about VW. We already knew that V was a midpoint. What else? What other information can we gather? Christina? VW is definitely parallel to SR. Excellent. These two sides are parallel. What else do we know? Emma?
That RW and WT are congruent
RW and WT are congruent. Excellent. How do you know that?
because it's the W is in midpoint.
Very good. And now there's one more piece of information. It involves the length of VW.
Oh, it's
Gabby?
VW is half of SUR.
Excellent. VW is half of SR. Very good, right? So, but we know VW is 57, and this is asking us to find RS
Oh.
or SR, right? It's the same, just reverse. How would we do that?
Times 2.
Yes, just multiply it by 2. So we're going to plug in VW, which is 57. So we get 57 equals 1/2 SR, and you just multiply everything by 2. 57 times 2 is going to give me 114 equals SR.
So like that thing from the start.
Last steps.
Could have done one thing from the start.
That VW is half of SR and then multiply times
Yeah.
2.
Mm-hmm. Yep. Now, I wanted to fill in the entire diagram because this mid-segment stuff is completely new, right? So I wanted us to be able to fill in the entire diagram based on that.
When we have a question like this, or mid-segment, we have to do all of that.
No. Nope.
So we're just doing that.
I'm just doing it for this example to show you all the stuff that the mid-segment tells us.
Oh,
Okay? Now, what you guys would need is only what I wrote down where UV is 1/2 this, and you would only need to write down this. Okay? What would be the last mid-segment of this triangle?
That's great.
VR. Oh yeah.
I'll give you guys a hint. It's not, there's no line on it right now.
Oh, VR.
Oh, U to W.
UW.
What? How is? Oh yeah, because it's half. Because they're like.
It's from midpoint to midpoint, right?
Yeah.
Okay? So UW would be the last mid-segment. And it's parallel to?
ST.
It's parallel to ST. Okay? All right, let's do example 2. All right, example 2. Given R, S, and T are the midpoints of the sides ABC, complete the table. Okay?
We do this thing and then we do it by ourselves and then.
Yeah, Savannah, give it to me.
I got ST, and
Okay.
it's 9.
You got ST to be 9. Do we agree?
Yes.
Yeah, she's right. She's right. How'd you get it? How'd you get it?
First, I saw ST is parallel to AC,
Mm-hmm.
and then using the midpoint, it shows that it's cut in half,
Mm-hmm.
and so I use the what's it called, the formula, whatever equals 1/2 of
Yep.
ST equals 1/2 of AC, giving 9.
Remember, so every mid-segment, right, is going to be exactly half of one of the sides,
Yeah.
right?
Divide by two.
So ST is parallel to AC, which is exactly what Savannah said. So this one has to be 9. It has to be half of the 18. What about RT? What's RT? Emma?
RT is 6 because AB is 12.
Yeah, perfect. Okay. And then RS. 7. Okay? It's exactly half the side that's opposite it. Okay? Now, for part B, okay, you have to make sure that you erase everything.
Oh, goodness.
Okay? What would AB be? What'd you get, Giselle? 20. Excellent. Okay? Because RT is 10, right? So you just multiply RT by 2 and you get 20.
Oh, it says it.
From it's already filled in. Okay? Now, ST, we don't know. What side could help us figure out ST? Emma? AC, which is 22. So if AC is 22, you just divide by 2 and you get 11. Okay? And then RS is going to be half of 15.
7.5.
So it should be 7.5. All right, and for the last one, if AB is 10, then RT should have been 5. ST should have been, if ST is 9, then AC should have been 18. And if RS is 7.8, did anyone get BC?
15.6.
15.6.
This was supposed to be easy.
Example 3. Use the triangle GHJ, where ABC are midpoints of the sides, GH of the sides. If GH is 7x minus 1, so let's fill that in there. This is 7x minus 1, that whole side. And BC is 4x minus 3. Okay. What is GH? Well, we can't know what GH is until we figure out X. What is the relationship between GH and CB? Hold on. Okay. GH and CB. Giselle?
CB is half of GH.
Excellent. CB is exactly 1/2 of GH. Okay. Now, I'm going to show you a little trick. Okay. Because I don't like to deal with fractions. And I guarantee you guys don't like to either. Okay. So instead of saying that GH or CB is half of GH, we could write this as CB times 2 will give me GH. Okay? In other words, GH is 2 times CB. Do you guys see how I got that? You just multiply both sides by 2. Now, when I plug in my x terms, right, it's going to make this equation a lot easier. Otherwise, you would get 7 over 2 minus 1/2, and it would be nice and ugly, okay? So we just multiply by 2. Now, we're going to plug in CB, which is 4x minus 3. So 2 times 4x minus 3 equals GH, which is 7x minus 1. We distribute that 2 to both terms. What do I get when I distribute? 8x minus 6 equals 7x minus 1. And then what do I do from here? Emma, what'd you do?
I added the -1 to the other side, so it's going to give you 8x minus 5 equals 7x. And then I subtracted the 8x, which will give you -5 equals -1x. And then you divide by -5, x equals 5.
Yeah, x does equal 5, but
Or divide by -1.
there we go.
equals 5.
Divide by -1. And then we get 5 equals x. Perfect. Are we done?
No.
No. Why not?
Because you have to plug it in.
You have to plug it back in. Very good. So we're going to take that 7x minus 1, and we're going to plug in x equals 5. We're going to get 35 minus 1, which is 34. So the length of GH is 34. What's the length of CB without plugging it in? 34 divided by 2, which is? 17. 17. Okay? All right, any questions on this one? We're almost done, guys. We're almost done. I will wait another second. 4 involves, now we are putting our triangle inside a coordinate plane. Okay? So we have to find the mid-segments, and we have to find whether it's parallel and half the distance. Okay? So go to the next slide. Let's go back. What would you do to find the coordinates of D and E? What would you use? Mariana? Very good. You find the midpoint. Excellent, right? It shows us where D and E are, but let's also calculate it just to make sure in case it wasn't given to us, right? What if it told you find the mid-segment between sides AB and BC? Okay? And then you would have to do it all on your own. So let's do step number 1, which is find the midpoints. Okay? If you guys want to copy this graph and add it to a page between example 4 and the next slide, okay? That's a good recommendation because this one's going to require quite a bit of work. So the midpoint, which would be D, we would find by adding -1, which is the x-coordinate from B, with the x-coordinate from A. So we would do -1 plus 1 over 2, comma, 4 plus -6 over 2. Based on our test results, we're pretty comfortable with the midpoint. Is anyone still not that comfortable with midpoint? We're pretty okay? It's basically the average of each of the coordinates, right? So we're finding the average. We should get that D is located at 0, comma, -1. Which is exactly where D is on our graph. So that's a good check, right? Now, midpoint E is going to be a different set of numbers. It's going to be -1 still, but now plus 5 over 2. And then it's going to be 4 plus 0 over 2. So E is going to be at the point 2, comma 2. Okay, which is exactly where E is. Questions on step number 1? Okay, now we just proved information that was already given to us, okay? If it's given to you, you don't need to go back and prove it again, okay? This was just done in case they don't tell you where the midpoints are, okay? Now it says, show that the midsegment DE is parallel to AC, okay? Now let's go down to this next slide. So let's go back. Step number 2 is slope. All right, so we're going to find the slope of DE, and we're going to find the slope of AC. Remember, slope is just rise over run. So the slope of DE, we're going to count the rise and count the run. Up 1, 2, 3, to the right 2. So our slope is rise over run, so plus 3 over plus 2, which will give us 3 over 2. Go ahead, Talia. That's for perpendicular. Okay? This one, no, but I love it because that does involve slope. You're on the right track, okay? But when we're proving parallel, it is different than perpendicular, okay? All right, now AC, the slope, is going to look a little bit different, but is exactly the same, okay? Now let's show it. To go from A to C, we go up 1, 2, 3, 4, 5, how many?
6.
Plus 6, and then to the right, 4. Okay? So we went, our rise over our run is going to be plus 6 over plus 4. In other words, just 6 over 4. but we simplify it. What is the numerator and the denominator divisible by? 2. So this becomes 3 over 2. Do they have the same slope? So we put a check mark and we say they are parallel. Yeah, we found the slope from A to C, and we found the slope from D to E. Now, because DE is a midsegment, right, it should be parallel to AC. If it wasn't parallel, right, what do you think we did wrong? We calculated the midpoint wrong. Very good, okay? But if we did the midpoint right, it should be parallel. Do you guys see that? So what midsegment will be parallel to AB? Let's say we put the midpoint here and label it F. What segment should be parallel to AB? What do you think? Gabby? FE. Okay? This segment will be parallel to AB. And what segment will be parallel to BC? Yep. DF. Excellent. Okay? So each midsegment is parallel to one of the sides. Okay. Now, step number 3, it says, okay, show that DE is exactly 1/2 of AC. So let's jump to the last slide. So all we got to do is we need to find the distance of DE, and we need to find the distance of AC, and make sure that DE is exactly 1/2 of AC, okay? All right, so DE, step number 3, let's do it in red, distance formula. Okay, so the distance formula, if you remember, is DE is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared.
I never understood how you turn like a point in the thing.
Degrees.
Yeah, I mean, square root like this. Because that's not an actual number. Well,
This-
it is, but like, it's not, you can't graph it.
You can't graph the square root?
Can you?
Yes. Of course. That's for another day, okay? All right, so DE, the coordinates were 0, -1, right? And then E was 2, 2? Okay, let's make one of them x1 and y1, and let's make the other one x2 and y2. And let's just plug it into our formula. Here we go. So it's going to be 0 minus 2 squared. So the square root of 0 minus 2 squared, which was x2 minus x1. And then we're going to do -1 minus 2 squared. So plus -1 minus 2 squared. Okay, so we're going to get the square root. 0 minus 2 is just -2 squared plus -3 squared. What is -2 squared? -4. So this is the square root of oh no, not -4. It's +4. Because remember, it's -2 times -2. So we're going to get a positive value. And then plus -3 times -3? +9. Okay? So this is the square root. What's 4 plus 9? 13. Is that a perfect square? No. Can it be simplified? No. So just leave it. Okay? It doesn't have any factors. Does 13 have any factors other than 1? No. So you can't break it down at all. Okay? All right. So then the next one, we have to compare that to what length? AC. Okay? So we're using the distance formula for AC. Come on, guys. We're almost there. So let's make this one x1, y1, and this one x2 and y2.
How many points would it be worth?
A lot, okay? This one's going to be the square root of x2 minus x1 squared, so 1 minus 5 squared. plus y2 minus y1, which is going to be negative 6 minus 0 squared. So AC equals the square root. 1 minus 5 is going to give me negative 4 squared plus negative 6 minus 0 is going to give me negative 6 squared. All right, here we go. What's negative 4 times negative 4? Positive 16. And then 6 times 6? 36. So then we're going to get that 16 plus 36 is going to give us the square root of 52. Now, always look to compare. Right now, we have no idea that 13 times 2 will give us the square root of 52. So let's try to break down the 52. What's a factor of 52 that we can take out? 7? 6 times 7 would be 42. What can we take out of 52?
2.
Is 16?
2.
I don't think 16.
26.
2. I would always do, guys, if it's even, pull out a 2. Okay? So, what's 52 divided by 2?
26.
26. Okay? Can you break down 2 at all?
No.
No. Can you break down 26? Yeah. So we're going to say, okay, this is the square root of 2. Leave that one the same because that can't break down. But we can break down 26 into what? Square root of 2 and the square root of 13. Uh-oh. Do you guys see anything? What would the square root of 2 times the square root of 2 be? Just 2. It is 4, right? But it's the square root of 4, which is just 2, right? Oh. So, what do we notice about 2 times the square root of 13 and the square root of 13? Is one half the other one?
Yeah.
Sure is. Okay? So, remember, we were proving at the end that DE equals 1/2 AC. I will leave it there, okay? So don't calm down if you didn't get it, okay? We're proving that DE equals 1/2 AC. Okay? So now DE was square root of 13. And then 1/2 times AC, which is 2 times the square root of 13. 2 times 1/2 is going to give me? Aren't they going to cancel? And we're just going to get the square root of 13 equals the square root of 13.
Mr. Garrett, you have 10 minutes to do your extra credit thing.
I know. I'm aware.
Wait. Oh, yeah,
And we're going to break it down, okay? Let's break it down step by step. So first step is how could we find the coordinates of D and E? So on the next slide, just put, we're going to use the midpoint formula. Okay? Now, this example is way easier because it already shows you where D and E are, right? But what if it didn't show you, okay? You would use the midpoint formula to figure it out. What's up, Talia?
Doesn't it already tell you the coordinates?
Yeah, that's what I'm saying, okay? So it does give us the coordinates for this exam. How will you show that mid-segments are parallel to each other? How would you show that something's parallel? What do you need to show something's parallel? No, not the parallel marks. Giselle?
We need to have the midpoint triangle.
No.
Midpoint second?
From a graph, how do we know that two lines are parallel?
They have the same coordinate.
Slope.
Xavier? They have the same slope, okay? So we need to find the slopes. Okay? So we need to find the slopes and just prove that they're the same, okay? Because if the slopes are the same, then the lines are parallel, okay? What do you think we're going to have to use to show that DE is exactly 1/2 of OC?
Midpoint. I have to go see the what it is.
No.
The mid-second theorem.
Nope.
No.
The distance formula. Our absolute favorite. Okay? The distance. All right.